What do we got?
Whew, I don't know. Drive by, drive over, dump and drive away. Here, you take a look.
This dude's a mess. Any DNA evidence yet?
Nope. You got something. We got this right here. But this hair is too brown and too coarse to be from this victim, so I don't really know.
Let's take it back to the lab and see if we can figure out what happened here.
All right. Whew.
I'm not touching this dude with a stick.
Yeah, let's get a cleanup crew after this guy. This kid's a mess.
Oh man, stupid deer ran right out in front of me. Oh hey, have you ever seen those CSI shows where they use DNA evidence like hair or blood to help find a criminal? Well, in reality, not all DNA tests are used to solve crimes. In fact, more and more scientists are using DNA testing to help identify if a person is a carrier of certain genetic diseases. But what are those tests? And what can they tell us about our genes?
So to learn more about DNA and genetic diseases, we're going to go talk to an expert. Let's go. Why is it important that we know about genetic diseases before we see them?
Well, it may make a difference on treatment. It may make a difference on how soon something comes to light, and it may, affect somebody's long-term care. It also makes a difference for knowing what your chances are of passing your genes on to your children. And that makes a big difference for your own planning for your children, or maybe your brothers and sisters want to know if there's a genetic disease in the family.
One genetic disease that Dr. Spence helps diagnose and treat is hemophilia. This blood clotting disorder affects about 1 in 10,000 males, yet only 1 in every 100 million females.
All of us have 46 chromosomes in every cell of our body. We inherit 23 chromosomes from one parent and 23 chromosomes from the other parent. So all of our chromosomes are in pairs. One pair determines whether it's a boy or a girl. Girls have 2 X chromosomes. Boys have 1 X and 1 Y. Boys, if they only have 1 X, the X they got from their mother, then any gene that doesn't work on that X chromosome would show itself by the disorder, whether it's hemophilia or any other X-linked disease. And when you only have 1 copy of that gene, if it doesn't work, that's all you got. The mother usually has 2 X chromosomes, and the other gene on the other X chromosome works fine. She passes on the abnormal gene to her child, but the normal gene makes up the difference in her, so she doesn't show signs of the disorder.
Aha! So that's why females are usually just carriers of X-linked diseases like hemophilia. Hey, wait a second. This is starting to sound historically familiar.
Oh, hello! Did you know that hemophilia played a key role in Europe's history? The disease was passed down through several royal families during the 19th and early 20th centuries to descendants of Queen Victoria of Great Britain, who was actually a carrier of hemophilia. Then her children married into imperial families in Russia, Spain, and Prussia. Yes, I'm quite sure they had to learn several languages when they were in school. And by looking at their family trees, we can trace the appearance of hemophilia in all of those royal families.
Even with today's science, doctors still use family history to help determine if someone might carry an X-linked disease. They call it a pedigree, and Dr. Spence checks 3 generations in much of the family tree. Of course, he uses science too.
We draw blood, only about a teaspoon of blood, maybe 2 in some cases, and doing either sequencing of the gene, look at the actual gene sequence, or look for missing segments like deletions, or other rearrangements of the gene itself. And even if one parent's a carrier of hemophilia, the mother's a carrier, we can provide genetic counseling to tell her what their chances are for having a child with a disorder, what the disorder means if she's never had to deal with it, and what tests we can do along the way, even during pregnancy, to detect the presence or absence of the disorder.
Now it's your turn to become a genetic detective. Research online to find at least 3 of dozens of genetic diseases that hospitals screen for in newborns. You might be surprised at what you find, as you
Never stop exploring your world.